When I first encountered JupyterLite, it blew my mind. The fact that you could now have a version of a notebook running in your browser using WebAssembly is a step change in open science. In this tutorial, I'd like to share to you what I've learned about using JupyterLite, including how do you access local files, external files, and what are some of the limitations of it. And in the second half of this tutorial, I'm going to talk you through some of the technical setup for JupyterLite. How do you get this running yourself to share your own computational models, and introduce you to some templates that can help speed up that process. So let's start with the fun stuff first. Okay, so in the description below, you'll find a link. If you click on that, it'll take you to the Open Science Nerd GitHub and the JupyterLite repository. Now don't download anything. Instead, if we pop over to the right-hand side, you'll see a URL link to GitHub pages. If you click on that, a JupyterLite website will open. And indeed, if you look at the URL for that, it's pointed at the Open Science Nerd GitHub pages site. Now, what's actually happened is that your browser, whatever you're using, has downloaded a static asset from GitHub pages. That contains what you can see here with the repository contents and notebooks and markdown and associated files. But the cool thing is that it also contains a Python environment. In this case, using the Xeus-Python kernel and some other files, packages such as NumPy and Pandas, all of which has been compiled to WebAssembly bytecode. Now, this means that we can execute Python code without needing to install anything on our local machine. So for example, I can open this notebook here and I've got versions of SymPy, NumPy, Pandas, etc. already available to me to run. So if I just run that like I would normally run a notebook, you can see that I've loaded SymPy version 4.1.1. I can run this cell as well. You shouldn't expect quite the same performance you would get if you were running this natively on your own machine in a normal Python environment, but it's pretty close. So all of this is within your browser's cache. So any changes you make to files within this repository are persisted within the cache in your browser. So for example, if I create a new notebook, okay, that is now stored within my cache. So I could, for example, close down this web page. I could reboot my machine if I wanted to, and go back to the JupyterLite GitHub, click again on the GitHub pages website, and what it will open is the persisted data on my local machine. So we've got a pretty cool setup here, particularly if we've got users who might not have Python installed on their own machine for whatever reason. You can now deploy an interactive notebook to them. They can run that, test it, make changes. That might be useful with students as well. If you have students and you want to teach them something, it means that there's no setup overhead for those students. One downside is that you need to ensure that people remember that if they clear their browser's cache, they will lose the data that they have changed. So if, for example, I'd created a notebook or edited a notebook on my JupyterLite site and I wanted to keep that permanently, I would need to right click on the file and download that to my local machine. Okay, so you've got one here called new, and one I downloaded here earlier, the urgent care model. So they're now stored in my download files outside of my browser's cache, because for whatever reason, you may end up clearing your browser history. So if we just shut down our JupyterLite site and open my Firefox settings. So if I go to cookies and data and go to manage data, I look for the Open Science Nerd GitHub Pages site here, I can clear all the cookies and data associated with that from my machine, like so. So when I head back to GitHub and then click on the URL to GitHub Pages, what will happen is it will be slightly slower opening because your browser will again download all of the data and the precompiled Python environment from GitHub Pages. And any changes you had made are now lost. So that's worth bearing in mind. So let's have a look at some of the differences between JupyterLite and JupyterLab. And probably the question I get the most is, how can I use my local data with a notebook that's been provided through JupyterLite? And that turns out to be really straightforward. All you really need to do is use the JupyterLite IDE for that problem. So let's flick over to our notebook example, and just a few cells down from the top, we have a cell that loads some external some data from the data folder called edarrivals.csv, and it's displaying that using matplotlib. So let's assume I've got something on my local machine that I'm interested in using. I've got here a file in my downloads called edarrivals_scenario1, and I'd like to run the Python code with that revised data. All I need to do is click and drag that over and across into the JupyterLite navigator here, and you can see that the file now appears here. Actually, I'm going to put that within the data folder. We can click on that and we can see that it's just a simple 2-column data set. That's the same format as our edarrivals data set. So we can now go and edit our code here to use the scenario 1 data set. And if I run that, we get a slightly different profile that we're going to use with our analysis code. As well as files stored on your local machine, you can also download files from URLs. So for example, here I've got a notebook stored in another GitHub repository. If I copy that URL, I can go to the file menu and select Open URL, paste that in there, click on Open, and it downloads a new notebook to my machine, in this case sampling from statistical distributions in Python. So nice and easy to add additional files to your repository if you would like to. Let's take a look at how you could set up your own JupyterLite website. So if we head back over to GitHub, this is actually a template repository that you can use to create your own JupyterLite websites. A few things you need to know before you do that. So the first is we have 2 environments in here. We have the build environment and we have the environment that contains the dependencies that your code needs to run. So let's have a look at the build environment first. So you can see here that this contains the Jupyter Server and JupyterLite and JupyterLite Xeus. So this is used to build the JupyterLite website itself. So don't edit this file, leave it as it is. The environment file, on the other hand, contains the dependencies as if you're using a normal Conda environment for your code. A subtle difference is we have this additional channel here, which is Enscript Forge, and that contains the WebAssembly versions of key packages, which includes Python 3.11, Xeus-Python, NumPy and Pandas. So the more technical packages will need to have been compiled to WebAssembly, to bytecode for WebAssembly, for you to be able to use them. So that channel is included for that reason. we'll build the website shortly and see which packages are coming from where. And then we've got Conda Forge. So as normal, for example, you might pull a package like SymPy and Ginger 2 from Conda Forge. Now, any package that comes from Conda Forge needs to be no arch. So you can tell that by searching the package up and just having a look. Is it labeled with no arch? What I found is sometimes I forget that and I build the website and there's an error during the build process. And nearly always that's because I've picked a package which isn't no arch and I can't use it within the JupyterLite environment. I think an example of that was the Profit library for time series forecasting. So watch out for that when you're building things. So if you scroll down the README, you'll see everything that I've just talked through is explained down here, where things are coming from and how you can edit that. So for example, if you wanted to add in Plotly, you would just need to add that in there and it would pull it from Conda Forge for you. Okay, so let's use this template to create a new JupyterLite website for ourselves. So I just need to use up here use this template button. So I'll click on create a new template. Okay, so I'm gonna take that from the Open Science nerd over to my personal GitHub, and I'm gonna call that cancer model. I'm just going to create a computational model about cancer services. I'm going to make it public. So I'm going to create that repository. That'll take a few seconds while it clones it. And then there's a key second step we have to do immediately. You can see straight away there's a job running. I'll explain that to you in a moment. That's trying to build the GitHub Pages site, but that won't work. What we need to do is go to Settings, Pages. Instead of deploying from a branch, we're going to use GitHub Actions. Okay, and if we go back to Cancer Model, now what's happening in the background is we're running the workflow here, deploy.yaml. If we have a click on that, you can see that's going to run every time we push new changes to main. So you may want to think about changing that. Perhaps you would change it to each time you create a release, for example, or perhaps each time you merge a pull request. Otherwise, you're going to rebuild your website each time you push something to main. And of course, we're all excellent software engineers and we never push things directly to main because that risks breaking our production code. So we've got a number of jobs included in here. Basically, the environment is being built using MicroMamba. We have the command here to run the JupyterLite build. So you don't need to do anything here. It's all going to do it for you automatically. It's going to create that for you and then upload that artifact using this GitHub action here. So all fairly straightforward for you to handle yourself. And you can see that it's completed fine here. So let's have a quick look at that. So if we have a look at this part here, build the JupyterLite site. Scroll down. So these are the dependencies that I wanted to install. And if we scroll down again, we can see where each of these dependencies are coming from. So you can see, for example, Python is coming from Emscripten Forge because, of course, that needs to be compiled to WebAssembly bytecode. NumPy as well, for example, is coming from Emscripten Forge. But if we look at Ginger 2, which I'm using to convert some Markdown to LaTeX, that's coming from Conda Forge. And I think if we look for SymPy, where is it? SymPy, yeah, that's also coming from Conda Forge. So they're no arch distributions on Conda Forge, so it works all fine. So if we head back to the main page, now what you need to do is set things up so it works with your version of the model rather than what I set up. So you might, for example, click here and use your GitHub Pages website, which would be, in my case, point to the cancer model instead of to the original template repository. What I've included in here for you is also a citation.cff. So if you go into there, you could edit that to be your own details. That would mean you'd have a link here where people could easily cite your repository. And we have a changelog here. If you click on that, this again is for my local template, so you might want to modify that for your own computational model. And you'd probably go down here and edit some of these details within the README file as well. For example, you probably want my ORCID on there, etc. Okay, so that's the Open Science Nerd template, but we also have the JupyterLite team have a Xeus-Python demo available as well, which is a little bit different, but feel free to have a go with that. They have their own instructions down here as well. So for example, if we click on here, we can download the Xeus-Python teams, the JupyterLite teams repository, and have a go with what they've made available as well. And I'd just like to say a thank you to the awesome JupyterLite team for providing such a fantastic tool for data science and open science education and sharing, and look forward to seeing what else they offer in the future.